for sticking around here. We are talking about just like in the morning, Jingjing's session was talking about some of the results from the CalFlux Hub projects, the technology projects. So this panel is similar to that, but we're focusing on exclusively on field projects, the higher technology readiness level technologies. And these are projects that are going to be upcoming in the next few months to a year. So this is kind of our future directions panel. And we have 4 speakers from the CalFlux Hub team who I'll introduce. I'm not sure exactly what order their slides are going to come up in, but I'll introduce them in this order. So we have Tristan de Franville from Skycentrics, which is a technology provider. His company, he's the CEO and co-founder or founder of Skycentrics, and they provide a platform that allows connectivity to devices in buildings. His motto is, they're the universal remote for buildings. So if you ever have problems with your remote, see Tristan. Peter Grant is a researcher at Lawrence Berkeley National Lab in the Building Technologies and Urban Systems Division. That's Marianne's area of the lab. And his specialty is water heating, both modeling and field work on water heaters. So he's your water heating guy if you have a problem with your water heater. Joe Borg, you already heard from this morning, and you heard from his colleague Beth Reed, so you know a little bit about what Olivine does. They're a third-party aggregator that provides demand response and demand flexibility services to utilities and markets. And Joe is vice president and is the lead for their CalFlux Hub activities. And we have Keaton Chia from UC San Diego. He's a research engineer there, working in the engineering school, works on distributed energy resources, demand response, demand flexibility. And he's going to be talking about some projects they're doing on EV charging and batteries, stationary batteries for demand flexibility. Okay, next slide. Thanks. Okay, so this is, you saw this slide this morning from Marianne, and I think Jingjing showed this as well. And this was just to kind of direct you or orient you to where these technologies that each panelist is going to be talking about kind of fit in the universe in CalFlux Hub. So as Marianne mentioned, we have a lot of residential technologies. So we have pool pumps. Tristan's going to be talking about that. Several water heating projects that both Tristan and Peter will talk about, both single family, multifamily, and commercial. Tristan is doing some commercial HVAC programs as well. Joe is also doing commercial HVAC. They have a project at Santa Rosa Junior College that's using large commercial HVAC systems for demand response. And then Keaton will be talking about EVs and stationary batteries. So I think the theme here really is within CalFlux Hub, we're trying to expand the portfolio, include more types of technologies, more types of buildings, and really kind of cover this, this landscape that, in Sarah's talk, she kind of mentioned all the different end uses, all the different sectors. To really get to those potentials, we're going to have to tap into all these different end uses, building sectors, demographics. And so that's kind of the theme here, is that these are our upcoming projects where we're working to kind of fill in the portfolio of the technology research projects. So with that introduction, let's go to the next slide and see who's actually talking. This is somewhat random here. Next slide, please. Drum roll. Next slide. Is there another slide? Okay, there we go. Okay, Peter, you're up first.
All right, looks like I win the game of roulette. So I'm here to talk to you today about some work we're doing developing what I call, I'll move over to the other side so I'm not blocking these two, what I call price and load responsive control for water heaters. And the state of the industry is really that there have been huge advances in water heaters in the last few years that enable communication, And these communications allow us to implement load shifting controls that really balance out the duck curve. But the state of the market, or the state of the art in load shifting, is that typically people create one load shifting control strategy and send it out to every single water heater in the entire fleet. But when we think about what really happens in buildings, people consume hot water differently, right? One house has one occupant, another house has 5 occupants. They use hot water differently. People also pay different electricity prices. House A is on an EV rate, house B is on a non-EV TOU rate, right? And so there are different baseline load curves, and there are different economic incentives for load shifting. This means that we should create customized load shifting control strategies for different houses. And so that's what LBNL has done. And you can see this in the kind of the 3 plots down at the bottom, where we're talking about the different realities on the top 2 plots. And then the bottom shows how you can create different load shifting control strategies for different groups. And in CalFlex Hub, we're about to start up a project where we do field demonstration of these controls on 120 volt heat pump water heaters. Now, for the rare person who doesn't spend 40 hours a week thinking about water heaters, I'm sure there are 1 or 2 of you here today, these 120 volt products are a really big deal, right? Traditionally, heat pump water heaters have used 240 volt, 30 amp electrical service. And so when you're trying to replace a gas water heater, which doesn't require that electrical service, you probably have to pay an electrician an extra $3,000 to $5,000 just to make that electricity available. The 120 volt units plug into a standard wall outlet. So we're really thinking that these can help retrofit all these gas water heaters over to heat pumps. And we're thinking these controls can really help with that transition. Next slide, please. So this shows the communication architecture that we intend to use, and it shows kind of the whole process. We're up at the very top. You have either the utilities or maybe the Energy Commission's Midas platform releasing electricity prices, which go out to the cloud. Then we can have our control platform, which receives these prices and then identifies high-performance load shifting control strategies for different archetypal heat pump water heaters. We then present these load shifting control strategies to aggregators, so people like Skycentrix or like Olivine, who can then send the signals out to the fleets of heat pump water heaters that they are managing for the program. And the communications could either happen via CTA 2045, which, as you heard from Reem earlier, is now required for all heat pump water heaters sold in Washington and Oregon, which hint that basically means they're on all heat pump water heaters sold in the country now, or could also be sent via Wi-Fi. And some manufacturers do include Wi-Fi communications, so we can just send the signals via these existing platforms. Next slide, please. Okay, so this is a new project. We were a pretty late addition to CalFlex Hub, so we don't yet have field monitoring results to show. We've just finished recruiting 9 out of our goal of 10 sites, so we expect testing to start this month, but not quite yet. So this is a sample simulation result showing what happens when one manufacturer's products, based on our simulation model, which matches those manufacturers' products quite well, respond to a highly dynamic price, which is shown on the top. Ideally, what you would see is that we shift load away from times when the price is above average, which are shown by the periods with the red highlighted background, to times when the price is below average with the white background. The blue line shows the manufacturer control logic, just standard feedback controls, no load shifting attempted. And the green shows what happens with LBNL's price and load responsive signals. I forgot to point out, this is a fleet of 148 heat pump water heaters, all responding to monitored hot water use data. So ways people really behave in homes. And so you can see we're actually shifting that load straight away from the high price periods and actually right towards the solar peak. So we're really helping stabilize the duck curve. Quantitatively, this showed 29% cost savings. We've done some other simulations since then, which showed that it's typically going to be somewhere between 15% and 40%. So this is real bill impacts for participants. Meanwhile, we've reduced the peak period consumption by 75% and increased the solar peak consumption by 102%. All in a water heater where nobody actually notices any difference in performance. All we've done is make the water hotter at some times of day, and then a mixing valve makes sure they get the temperature of water they were expecting. Next slide, please. Okay, and this is the last one. So just some key learnings. And since this project's pretty new, these are pretty preliminary pre-learnings. But we know that a lot of people have struggled with human subjects protocol process. And one thing I want to share is that it's actually pretty easy if you go to their office hours. You can just stop by and ask them questions and they'll point you in the right direction. And then you're really likely to get approved. So I'd recommend doing that. Another is that we've really shown through simulation that instead of applying one control strategy across the whole fleet, you customize it based on typical behaviors, you can really drive much better results. So this is something we're really looking forward to exploring out in the field. And finally, we need to focus on really easy deployment. One thing that we focused on when developing this is that it only uses existing sensors. It only uses existing communication protocols. We're not asking manufacturers to change products. We're not asking plumbers to change practices. We're just using what's already there. And as a result, we now have utility programs asking us for help because it's something they can easily implement. And I think that's really key. Thank you.
Okay, next slide. Joe, you're up.
Fantastic. So earlier today, we've heard a lot about this idea of what do you do with multiple devices in a facility and how can you optimize those? And in response to dynamic prices. And so one of our projects that we are pursuing right now, we're in development, it's with Santa Rosa Junior College. And it's a very unique application, but I think could have very broader applications, as we demonstrate this. And that is this idea of using a battery-backed HVAC load shape, right, or load shift, meaning that based on what the outside temperatures are, you first go to HVAC. You go to the air conditioning load as your first level of response. And then if the prices are such that it's economical, you can then dispatch the battery to provide a firm resource. And that could also inform bidding in wholesale markets. If wholesale market prices were high, what is the value of adding extra battery capacity on top of the HVAC to get additional load reduction? And again, that's this idea of getting multiple value streams from multiple devices within a facility. And so Santa Rosa Junior College is a relatively small campus, but it has 26 buildings, and it is a microgrid. Now, we are not using it as a microgrid application in this project, but we are using the microgrid controller. And that's one of the things I think we're seeing with a lot of the projects throughout CalFlex is that we transition to dynamic pricing. And in response to dynamic prices, we're still kind of constrained by using legacy systems that were designed for demand response, right? And so we are constrained right now with this project in terms of it's designed for a microgrid application. It's not even designed yet for demand response, right? And so we're dealing with some of the parameters of the facility that include the islanding requirements, right? And so we're using kind of islanding requirements as the baseline for doing demand response and also load flexibility. So with that, we expect about 250 kW, up to 250 kW of load shift. And so one of the things we're excited about this project is that it kind of rounds out the CalFlex portfolio of looking at a larger commercial building that includes both batteries and HVAC. Next slide, please. So we are going to be doing our functional test in a couple of weeks. We've completed our integration with the microgrid controller company PICE. And then we will probably wait until the spring when we have higher temperatures to test the HVAC. The communication architecture, it's a little bit different than the one I showed you this morning with Ecobee, in that similar to the one this morning, Olivine ingests the CalFlex Hub prices into our DERMS platform. We do the optimization, and then we can submit a dispatch to PICE to optimize the facility loads at whatever duration and quantity of KW that we call for. All right. And so next slide, please. So I want to spend, most of my time, remaining time on this slide, and that is what we expect to learn from this, right? Our hypothesis is that as outside air temperatures increase, that there will be kind of this V-shaped curve, if you will, of when temperatures are lower, there's not enough HVAC load to reduce, so we'll need more battery. And conversely, as temperatures go up, right, there won't be any HVAC load to reduce because it's going to all be needed to keep up with the increased set points. So we expect to see some kind of V shape. This is just our hypothesis of what this is going to look like and what the battery firming is going to be needed for this resource, which would then inform different dispatch levels that we could do cost effectively and for different services. And so really what we want to do is develop this algorithm at the end of the day that will tell us at which temperature, how much battery we need, and how cost effective is it for us to dispatch the battery at the levels that we want. So with that, I'll turn it over.
Great. Thanks, Joe. Okay. Tristan, there you are.
All right, thanks. Hello, everybody. Check. All right. So we have a whole bunch of different sites. The PowerPoint that you actually get will have the list. So pool pump sites, 20 of them residential, water heating, a couple different ones. So we've got 2 commercial multifamily, very excited about multifamily. Then Bay Area cities all over the place with fire stations and civic centers and city halls all have water heaters, and nobody notices except when they go wash their hands. So that's pretty easy load to shift. And then there's one other one that'll come to me. So what we believe is that it's critical to try and find a pathway to the loads that you can shift without impacting comfort. And, power to the thermostats. They got us out there involved in all this. But if anybody's been in a home, it's definitely, you can feel it when it's a little bit colder, a little bit hotter. So water, pool pumping, easy to shift if we can get to those loads. Next slide, please. So this is how we do it. We connect to the Olivine server, of course, CalFlex Hub to get the prices. Then we translate those price shapes into action shapes. We deliver them down to the Skycentrics CTA 2045 EcoPort module, and then to the pool pump controller. Yep, Pentair has made one with the white rectangle there. That's the magic port that we want, or the water heater. And then we got really tired of waiting as a company for devices with the port. So we invented Skybox so that we could actually talk to machines by Modbus and BACnet and give them a port, so that we could just have more ports out there. So very excited about this. This is what we're doing with the multifamily heat pump, large heat pump commercial water heating systems. So next slide, please. So pretty exciting. Pentair in their pool pump put algorithms where we can shed, and then you can see by that arrow in the middle graph that we shed it and then it extended automatically its pool pumping time, so that the customer gets their regular amount of flow through that pool, which is critical. That's how they know that their pool chemicals are being distributed the right amount every day. And then later we load it up, which is that purple spot on the lower, and you can see that it got pushed and it actually decreased the amount of time of the flow. And there's some super interesting math, because why is it a different amount of time? And it's because if you decrease, it's a 1-to-8 inverse relationship between flow and power. So if you double the power, or if you cut the power in half, you're actually decreasing the flow rate by 8 times. Pretty interesting. So that was the pools. And just while we're here, we want you to know that we actually are doing a gas demand response program by optimizing hotel and commercial heat pump, commercial heaters of pools that we wanted to mention, because it's pretty exciting to be optimizing gas. That's part of the decarbonization story. Next slide, please. So this is a graph of a heat pump water heating system in Seattle. We don't have the data for our two heat pumps that we're installing in Menlo Park, but they're very similar, about 100 apartments. And this was done by Ecotope, and it just shows the blue at the bottom, the red you can barely see, but the blue at the bottom, these multifamily large heat pump water systems, central system, was able 95% of the year to turn off for 2 hours in the morning, right at the morning peak, and 4 hours in the evening, 95% of the days of the year in Seattle. We think that in California, we have lighter weather, so warmer inlet temperatures, and we expect to be able to do it 100% of the year. And then what you see with all of this is that Ecotope is really good at calculating sizes. So if you have more storage capacity in the tanks, then you can more guaranteed, like all those ones at the bottom would have been 100% of the days of the year, they could have done that critical load shift. Next slide, please. So that is a picture of a water heater with the controls, EcoPort, in a Bay Area city hall. And some of the key learnings are pretty interesting, right? So we found out that the pool pump controller, speaking of DR, there's been sort of the battle of DR versus shifting every day. And EPRI and others had asked Pentair to make the algorithm that would guarantee the same flow. And Pentair said, okay. And they thought the whole time that there's going to be one DR event per day. And we want to do prices to devices where there's a number of times per day where it's going to go up, it's going to go down, it's going to go up, it's going to go down. So their algorithm needs to be rewritten to accommodate more than one CTA 2045 event per day. Multifamily is a huge opportunity. People are figuring that out because it's one owner, it's one system, it's a much bigger system. And by the time you incentivize the system to go in, the connectivity for a little bit of cellular over 10 years even is minuscule compared to the size of the system. So a lot of work has been going into multifamily, and we think that's a big opportunity nationwide. And then cities, it's interesting there, as I said, really easy to shift them. Fire stations tend to have the big loads, lots of showers, lots of clothes washers running all day, all night in fire stations. So other than that, it's easy to shift loads in water heaters in governments. How did I do? All right.
Well, thanks very much. I'm presenting on behalf of Professor Jan Kleisel at UC San Diego. Excuse me. I went to Berkeley, so it's good to be back home. But UC San Diego, along with our team, Christian, Shu, and Graham. So we got to perform 2 field tests to see how effective it is to dispatch DERs under different price policies. And here you can see our architecture where we have the CalFlex Hub signal being sent to 2 different systems at UC San Diego. We have the battery storage system on the right there for campus, and then a fleet of EV chargers, and we use 27 of them for this demonstration. So next, please. So here for the electric vehicle chargers, it's similar to Peter's graphs. You can see the price signal there where we have 2 peaks, high prices in the morning and then high prices in the afternoon. And you can see 2 curves there, the red one, which kind of reflects the standard charging strategy right now, where vehicles arrive and the system prioritizes quick charging to meet their needs. But of course, that's earlier in the day with high prices. And so in the gray there, you can see that there's a shift there where we do take into account the price signal, and that is now shifting load as well as reducing the cost. So the figure on the right, or the table, you can see that the majority of the energy dispatched is under 10 cents when you factor in that price. And the next slide. Battery was pretty straightforward for us, I think. In this case, we are dispatching the battery when prices are high and charging when it is low in the middle of the day. So in this case, we ran it over several different type of price curves. In each of those cases, it was profitable. Of course, with the 2 peak high prices, that was the most opportunity because you have 2 chances to dispatch the battery. I think one takeaway I want to kind of highlight with regard to EV charging is that in this case, we are focusing on workplace charging, and this is a great opportunity for leveraging prices because there's a lot of customer flexibility. You have people there for long layovers, and it's predictable. They're coming in for work, and their vehicles are sitting there. So I think as we look at different modes of electric vehicle charging, it's important to really take into account where that customer flexibility is and taking advantage of that. So versus charging at home or using DC fast chargers or public level 2 chargers. So catching us some time.
Thank you to all the panelists. Okay, I'll start off with a question. I'll try and save time for audience questions. So I'll just offer one to the panel. So for each of you, based on the experience that you've had in your projects, either from actual deployments or the modeling you've done, the preliminary work you've done, what do you think is the biggest challenge to scaling these technologies? When they actually get out of the lab and get rolled out to a bigger population, what's going to be the key thing that needs to be overcome? So why don't we just go down the line here? So Tristan, if you want to start.
One little story that goes with it. It was the pools. We couldn't get people to sign up for the pools. We were offering them a free IntelliConnect with grid connectivity because it had a CTA 2045 port, but we were offering it. Pentair had the list of people who had already bought the first version that didn't have any grid connectivity, but provided them remote control and visibility and scheduling from their phone over their pool. And they're like, okay, you're giving me something that can give me all that plus grid connectivity. Oh, I'm busy. Kids are howling. And then we went to the people who had the pump only, but didn't have the connectivity. And we said, hey, we're going to give you this thing that gives you remote control, scheduling, alerting, and everything on your phone and has grid connectivity. And of course, they wanted that, the thing I just said. So I think that's it, right? If you give something that they want, they don't mind the grid connectivity. But if you start talking about grid connectivity without anything they want, it's not a good conversation.
So in the kind of the old energy efficiency world, that's non-energy benefits. So we have to deliver some other benefits along with the price, the bill savings or whatever. Yeah. Okay, Peter?
Okay, so I'm having trouble choosing one, and therefore I'll share two. One of which is that any sort of predictive control needs to have a pretty good understanding of how people are going to consume services throughout the course of the day. And domestic hot water loads are really random and really hard to predict. So we need to make sure that we're doing a lot of good research to get that right. And actually shout out to Wei Ping in the audience here, who just yesterday started applying machine learning tools to data to try to answer that question. So we're making progress there. And two, of course, is market trust, right? We're creating these schedules and telling people you'll get great results if you send these signals at these times of day, but they need to deploy them in the field. They need to see it work, and they need to build trust that we're right in order for the market to really adopt it.
I think I already alluded to one of the challenges in my presentation, and as I mentioned, I think it's prevalent across a lot of the projects and a lot of the devices that are out there, and that we have spent a lot of time over the last 5-10 years, developing devices and technologies that are for demand response. And so, Tristan, to your point about Pentair, like they designed it for one DR event per day, right? And so, dynamic load shifting is all about an hourly load shift. And so, for example, with the Santa Rosa project, which is designed for a microgrid, and it's hard coded in their algorithms that the HVAC has a set point of plus or minus 6 degrees. And so we anticipate that there may be some complaints about a 6-degree temperature increase in the buildings. We don't know because we're still not unsure about the occupancy rates between 6 and 10 of those buildings. Maybe it won't be. But I think there's this hurdle of getting over and being able to provide more flexibility within the algorithms of the devices.
And I think for us from the implementation side, there was a lot of manual work to do this demonstration. We were manually uploading price signals and manually downloading data. So I think the technologies will catch up to be able to take in these signals. But I think from a adoption side, especially on the EV charging side, managing customer expectations is a big challenge. Especially with these systems that can operate in the background is great. But when I go in to plug my vehicle in, I have high expectations of reliability and predictability. I think that'll be a major hurdle.
Great, thanks. Do you have any online questions?
Yeah, there
Scott,
are
in the chat?
two.
Oh, good.
There are two
Okay.
online questions. Oh, hold on. It's the Brittany mic, so I got to make sure it's all right. There we go. Keaton, these are both relating to your project. So the first is, was EV demand flexibility through managed charging solely through scheduling, or were there any aspects that were V2G, V2X, or bidirectional power flow? If not, is this being considered as a next step?
Okay, if people online didn't hear that. So the question was about the EV charging project and whether it's just managed charging, so unidirectional, just managing the one-way flow of power, or whether it involved V2X or bidirectional charging.
Yeah, in this case, it was unidirectional. So this was using PowerFlex's ALM, or adaptive load management. That was the kind of the baseline curve you saw there, where it will change the power flow based on the duration of those customer charging periods. But when you add in the price signal, then yes, there was some scheduling to kind of put caps on when the EV charger is dispatched. So, but that was through their own optimization algorithm.
Thanks. And I should mention, CalFlexUp does have a bidirectional charging project that's done some initial testing. Unfortunately, Tim Lippman, who led that, wasn't able to make it today. But so there is some work being done on bidirectional charging in CalFlexUp. Is there another question?
There is, on the same project and in a similar vein. Was there any power export or ancillary services through the battery energy storage system associated with the project? And if not, is that being considered?
Okay. Could you restate the question? Just
No problem. Yeah. So the question was whether there was any battery exports that were interacting with the EV charging. In this case, it was a separate demonstration, but that's something that I think can be considered. In this case, we were kind of separating them to see that the battery, I think, again, operates kind of in the background. There's not really much customer impact, but the EV charging obviously has more of a direct interaction.
Sure. I'll add on to that actually for you, Joe. With your battery project, is there any export happening, or is it all self-consumption within the college there?
Well, it's currently self-consumption, but we hope the project will help define the economics of being able to export.
Okay. Thanks. I don't know, Peter or Tristan, if you have any comments on anything relevant there to your projects.
Yeah, I thought of one more thing. Thanks. So on the project that had the large multifamily, it is possible for them to shift the load and make it be completely invisible to the people that are doing it. So I think we just have to continue to really find those invisible loads. And HVAC, tricky part is not only for us. In fact, we've had a delay of this in the school districts because we want to get a baseline. We want to get real data. And I'm sure this is your situation too, right? HVAC is often controlled by thermostats, and you have no idea what the load is. Could be a big machine or a little machine. Whereas at least the pool pumps and the water heaters give us the data of how much power they're using. So we've had to go in and throw in some skyboxes and Modbus out to sensors to be able to measure the HVAC load.
Yeah, thanks. Any other online question? Okay, let's go to the room here. Yeah. Oh, actually, let's wait for the mic. Sorry. Oh yeah, we'll have to use. You know what? Why don't we do that?
On the topic of data, it seems like getting data of what power is actually being used by the water heaters, by whatever, is just like so helpful. And with the project with the custom water heater schedules, you had mentioned that it's like, you found it really important to not have to install any additional sensors. I guess like, is all of the data that you need coming from the water heaters themselves and it's already in the cloud, or were there additional, like, yeah.
Sure. Well, I'll say that all the data we want is most certainly not available, right? We would love we would love to have water flow meters installed on every water heater telling us what's happening, but that very much violates our rule of don't ask people to install new sensors. So we're just crossing that one off the list. But these CTA 2045 modules and the manufacturer APIs will tell you how much electricity the water heater has consumed. And so you can just ping it. I think, Tristan, you do every 5 seconds, 10 seconds. And you can just have a really clear picture of what the baseline load curve is. And so our plan is to assume we have no knowledge of the water heating or of the hot water consumption, and instead just go straight to the electricity and look at the baseline load curve and estimate people's behavior from that.
Just add one thing. So the nice thing about CTA 2045 water heaters is not only do they say when the power's on and off and how much power they're using, because for heat pump, they can be on the compressor for about 800 watts or on the resistance for 4,500, but they report their estimated storage capacity. And so as it cools off, you see this storage capacity number rise. And then when somebody does a draw like a shower, you see it go, and really, so you do get some sense of that. And I'm sure you're going to use that with ML over time.
We're going to try. Yeah, we'll see how it works.
Let's go to Anna. We'll get to you later.
Hi, so interesting. You both talked about controls on the OEM side of things. Is it always going to be necessary in the business model sense for a control platform in the middle to convert prices to signals and then send to the equipment? Is there no other possibility of the device themselves taking the price or taking some grid signal and doing the operation?
I think we all have inputs. Yeah. So I'll just make one comment from the water heater side, where the intelligence could certainly be on the cloud, and we're approaching it that way at this time. But we've also talked to a manufacturer who is now developing intelligence to put right on their water heaters, and we're collaborating with them. So I think it could be in either case or both cases in the future. I would say manufacturer interest, but I'm going to let these two dive in more. Oh, okay. So Anand asked, what are the factors that lead to that decision? And from my particular viewpoint, it's manufacturer interest. Right. They'll do what they choose to do. I'll respond accordingly.
Yeah, let me just say that the manufacturers in the CTA world, because Joe's going to talk probably about the non-CTA world. So we put in CTA 2045-B level 2 that they had to digest prices themselves. And almost all of them really said that was really hard for them. So what's really interesting is, as Pete said, it's cloud or module or device. The end game, of course, that we're all expecting is, in the device, digest the prices, do your smart responses there. But what we've learned over 10 years of working with manufacturers is, boy, they really are concerned and slow about firmware changes and hardware changes. Whereas clouds are super powerful and can easily do it. And even our module, we're not in charge of safety, they are. So it's easier and faster for us to change. So I think it's a normal progression to go cloud, module, and OEM.
Yeah, and I think you've just kind of touched on one of the third rails in this industry, and that's open standards, right? Being able to go directly to other manufacturers' devices and not go through their cloud, right? And so we can go, depending on the different devices and the ability of the manufacturers to allow us to, we can go directly to the device. So we can use our platform to basically optimize around prices, right? And then send a schedule to the devices. And talking with a lot of the OEMs, I think the future, at least on the residential side, is I think a lot of the devices are going to be controlled by a home energy management system, right? So that we can send the prices to the home energy management system, and that home energy management system optimizes and controls the devices locally, right? So there's lots of different ways to do it, but to Peter's point, it's a lot about the manufacturers allowing you access.
Yeah, and this gets back to the chart that Marianne showed in the morning with the 4 different kind of architectures that we've seen in the market. And one of them was a building gateway, which the home energy management system would be the building gateway for the home. Joe, I'm curious, at the junior college, what's the architecture there? Are you going to, you mentioned the microgrid controller, but then also it's going to the HVAC system. So there's some sort of.
So the microgrid controller then goes to the building automation systems. which then controls all the devices in 26 different buildings.
So it's essentially a gateway type of arrangement. Okay.
I just want to add one thing that we've learned, the most important lesson that everybody should take away, which is that if there are a few virtual power plants and a few ways of doing this where the schedule is kept in the cloud, and in my opinion, that's kind of a disaster, because the minute the cloud goes, these randomly cycling loads, which HVAC and water heating are, go back to random. And if you're counting on 13 million California residential water heaters to be a virtual power plant, and they go random any significant amount, that's really bad for the grid. So you want at least yesterday's schedule of prices to be acted upon by either the gateway or the device or the module locally, and continue to be a moderately well-behaved citizen until it's back online, not a random old style citizen.
No, that's a really good point. Okay, Wei Ping.
I have a question on EV charging. So I learned in the past about like a limitation of EV charging, where like once EV is plugged in, then like you cannot do something like you stop the charging for like 15 minutes and then turn back on. It has to be like one through. Do you see like this is an issue to like using EVs as demand flexibility programs? Do you see this as a challenge?
I'm not as aware of the, well, yeah, you want to maintain like a steady charge. But again, we've seen with PowerFlex, you do have that adaptive load management. So it isn't a constant power through the charging session. It will vary depending on what the optimization can provide or determines for that. So I think that is the future where it does need to be more adaptable. I think actually to expand on the question earlier about like integrating batteries and other resources for EV charging, I think there is a need for DERMS where you have that coordination between systems, and it can vary the output during those sessions based on, again, customer flexibility. So hopefully that answers your question, but I think that is a future need to have that.
Okay,
Thank you.
thanks. Are there any other online questions? How much are we at time? Okay, great. We're at time. So thanks very much for the questions and participation, and let's thank our panelists.
Well, I guess my face is being shown in the other room. I hope they're done with their session also. I'm assuming they're listening. So hello out there over in the building 91, the IGB, that beautiful bio building that that part of the lab has. First, I want to start by just saying thank you to everybody for coming today. So let's give ourselves an applause just for showing up. This was twice as big as we had planned on site. So it's because of you all wanting to be here today. I think it shows the importance and the interest in this topic. And I'm really excited to be at the end of the day on this first in-person CalFlex Hub Symposium. We did have a virtual one last year, but this is much better. You learned a lot more, I'm sure, than sitting in front of a screen somewhere and talking to people in the hallway and getting some good food and a beautiful day outside. I want to then thank the amazing organizers, Kula Addy and Jing just stepped out. And Scott up there manning the system. Great job, Scott, keeping it all running. And thank you so much. And all the Momentum team. So now I also want to thank all the speakers, because some of you are part of the CalFlex Hub program directly, and some of you are not. So thank you for those who traveled today to come join us. We really appreciate your joining us and helping us look at this. So I want to talk a little about some of my takeaways. I think probably one of the people that expressed it really well was Chris from Ream, when he talked about making it easy for customers. Customers want to know that their device is using it's using the most cost-effective time of the day. It's the cheapest electricity. Your device is going to run on the cheapest electricity. So it's smart enough to find that low price electricity. And that's something customers want to know. This device is smart and it's going to be the most cost effective charging. So compared to a normal water heater or a normal thermostat or a normal EV, yours is going to be more cost effective because it's being price responsive. That's really important. I also think that the concept that we talked about a little bit about value stacking is going to continue to be important. And I thought Beth did a good job of introducing us to the programs that the aggregators have been ramping up here in California. And they've been investing time in recruiting customers into programs for the peak demand programs in California to make sure we don't have power outages like we almost had September in 2022. So that was a scary year, a scary day for grid operators, and Ohm Connect came through with a lot of load, as many others did. So we want to acknowledge that there's been a big investment in that infrastructure. And Beth explained then, how do we move towards this hourly pricing concept and kind of bring customers into that next wave? And I also thought it was clear that from that same panel that Chris was in, I don't remember who said it. It might have been John, but it was about let's instead of doing pilots, let's start groups of customers to be on these programs. And I do think that we're going to do better targeting of identifying which customers have the technologies that are good customers for these load flexibility programs, and allow them to be some of the early adopters and get them on those programs. And the thing we all know about programs is the program has to be there for 5 years for us to know if it's going to make a difference. And we need to know the persistence of savings and the longitudinal performance. Because when we pay for a smart device to listen to prices, we, like Sarah showed, we expect a payback of so many years. And that program has to be in place for at least 5 years for you to get that payback. And that's one of the challenges in California, is we continue to evolve our policies and our programs, and we need programs that are in place long enough. So sort of when you sign up, I don't know what the DR contracts are. Are they 2-year contracts or 5-year contracts? What are those, Joe? When you 2 or 5? Yeah. So you're signing up for contracts, and I've heard a lot of folks ask about the VPP contracts in general, and what does it mean for customers to engage in these third-party programs. We did a lot of discussions today about customers, and I also thought that Sarah Outkalt's talk was a great summary. I hadn't seen her summary. I know she's been doing a lot of work, and she sort of gave high-level perspective on why would customers even want this, and how we're going to meet them where they want to be, to make it easy and to help them save money. So it's really important that we think about who we're talking to. In the CalFlex Hub portfolio, I think there's a lot more opportunity in small, medium, and large buildings that we haven't explored yet. And I'm excited about the Santa Rosa project. I would love to do more work with TES, but TES is hard to pay for it. I recently circulated a paper among my team from the late 80s, where we were paying a couple $100 per kilowatt for thermal energy storage around the country. There were incentives. SoCal Edison had incentives for thermal energy storage, and SoCal Edison had super off-peak rates back in around 1990, late 80s. So we've had phases of our energy systems where we invested in TES, and I think TES has a great opportunity, but we need those shift markets, as we were hearing from Nostromos, and we have to think about things that we can do in the California marketplace to innovate in that area. Another thing that I thought was particularly interesting was we heard clearly that we need to listen to customers and listen to folks in disadvantaged communities. And we like to imagine we know what they need and we want. And it's actually not easy to get them in the room, to go and meet them in their community, to understand, we think we're energy geeks, and they don't think about energy. They think about maybe their bill, but not the energy. So these communicating with those customers is really important. I also really like Therese Peffer's work with fans, because we know that there's some things we can do to improve comfort. And I also have to say that we know that extreme heat is a really important problem in California, around the country. And there's a lot of passive things you can do other than air conditioning, with better windows, with shading, with blinds, with fans. So air conditioning matters, but you want to do a lot of things in the building before you think about that, the air conditioning. And this last discussion was particularly interesting also. I thought the last discussion going into the question that Peter was talking about where, and Tristan, about the different ways where that communication with the heat pump might be, if it's in the cloud or on the device. And so these are evolving technologies. And we have a role in CalFlexSub to be conducting the work to help us understand what are the pros and cons of these different architectures, and how can we work with partners and the OEMs to make sure we're creating technology that people are going to understand, and that it's cost effective to communicate with, and that we understand both the business value in creating the connectivity and VPPs to interact with the device. And VPPs may be a price response activity where, as some have mentioned, that the third party is now helping you minimize your bill. And do you trust them? Is that what is the counterfactual for them to claim that they're reducing your bill? And right now in the T-Mix pilot with SoCal Edison, it's a shadow bill. So you can only save money. Your bill can't go up. And I think that concept could be really important in general for dynamic pricing. If there's a shadow bill and you can save money, but you're not exposed to the risk. So that's something to think about as we think about the technology. So again, one group I forgot to thank was the California Energy Commission. Our CAM, Matt Fung, is here. Thank you, Matt, for sponsoring us. I did mention thank you this morning, but you weren't here yet, but that's okay. And David Hungerford, who has a long history in this area too. Thank you, David, for your continuing support. Oh, and Andrew. Andrew's still here too. Thank you, Andrew, for Andrew McAllister for joining us today. So it's exactly 4 o'clock, and I have one more comment. Several people brought up today that we need to continue to collaborate. And we know that there's a lot of complexity. We have customers, we have aggregators, we have technology providers, we have utilities, we have technology developers, we have valuation and economists, we have engineers, and we have communications technology, and we have electricity prices. And so it really means understanding the activity and the innovation that's occurring across that space. So I thank you all for coming today. And I thank you for your own interaction. So hopefully we're creating a network that's going to continue to collaborate to help California in this decarbonization activity, and to create that clean, affordable, and reliable energy that we're all trying to organize ourselves around. So thank you so much, and we'll close out.